Hello and welcome to Victory Online Academy. This is Igcse physics session, and in this session we are going to learn about momentum. Momentum is a very important topic for Igcse physics, and every year question comes on both paper one and paper two and paper four, as well as in paper one and paper three. Right. So let's quickly learn what is momentum. So momentum is the product of mass and velocity. So momentum is given by this is represented by the letter P, and it is the product of mass and velocity. So as velocity is there and velocity is a vector quantity, that's why momentum is also a vector quantity. What is vector quantity? The physical quantity which is determined by both magnitude and direction, right? So both number and the in which direction the body is moving, that also very important. That's what vector quantity is. So momentum is a vector quantity, and it's a product of mass and velocity. Okay, momentum is product of mass and velocity. Okay. So this is the concept of momentum. Now, how this momentum is useful, we will discuss it with Newton's second law of motion. But first, let's determine the unit of the momentum. So as you know, momentum is mass into velocity. So mass unit is kilogram and velocity is meter per second. So unit of momentum from here, unit of momentum P is mass is kg and velocity is meter per second. So kilogram meter per second, that's the unit of momentum. Okay. So what is Newton's second law? Newton's second law of motion. So Newton's second law of motion, generally students know second law as force is equal to mass into acceleration. Okay. You might have heard about this resultant force is equal to mass multiply acceleration. But this is not the second law of motion. Actually, this is derived form of second law of motion. The actual form of second law of motion is force applied on an object. Force applied on an object is equal to rate of change of momentum of that object. So it means force, resultant force, is equal to rate means with respect to time. So force is change in momentum, that is delta means change in momentum over change in time. That's what Newton's second law of motion is. That if we are if there is an object here, and if we are not applying any force, this will stays over there. Okay. If it is moving with a constant speed, it will keep on moving with a constant speed unless we apply a force on it, and that force will increase or decrease the speed depending on which direction we are applying the force, right? So if we apply the force, so its momentum changes. So let's say initially it is moving with u meter per second, its mass is m kg. Okay. If you do not apply the force, it will keep on moving with u meter per second. But if you apply a force on it, the body will start moving faster, its speed will increase. If the speed or the velocity increases, momentum will change, because momentum is a product of mass and velocity. So let's say that initially it was moving with u meter per second. We After we applied the force in time t seconds, in time in total time t seconds, the body starts moving with v meter per second. Okay, so its speed has increased from u to v. So what is the initial momentum? Pi mu. Okay, mass into velocity. And what is the final momentum? Pf, which is mv, right? So if we applied the Newton's second law of motion, that force is equal to rate of change of momentum, that is change in momentum divided by time t. So you will see that force will be equal to change in momentum, that is final momentum minus initial momentum divided by the total time, which is t. Okay, so that's what Newton's second law of motion. So final momentum is mv, initial momentum mu divided by t. Okay, so if you take m common, and you can write like this: v minus u over t. And what is v minus u over t? This is acceleration. So mass into acceleration. So force is equal to mass into acceleration is derived form. So we derive it from this concept that force is equal to change in rate of change of momentum, that is change in momentum divided by time. Okay, so this is very important thing. And from here we can also define one important term that's called impulse. Okay, so impulse, if you multiply this time over here, so you will get f multiply delta t, which is equal to delta p. Okay, so product of force and time, which is equal to change in momentum, that is called impulse. Okay, so impulse definition is change in momentum. Okay, and the unit of impulse is the same as unit of momentum, because it is change in momentum, so that is kilogram meter per second. Okay, kilogram meter per second, or you can write Newton second. So unit of impulse is Newton second or kilogram meter per second. And we know that that change in momentum is force into delta t. This is unit is kilogram meter per second. So this unit of momentum we can also say Newton second. Okay, so Newton second is the unit of impulse or the unit of momentum, or you can write kilogram meter per second. Both are the same. Newton second is the same as kilogram meter per second. So both unit you can write in the exam. Okay. Now there is a very important concept that is called law of conservation of momentum. Law of conservation of momentum. And what is that law means? That, see, if we would not have applied this force F, the body would have keep on moving with u meter per second. It means the momentum would have remained mu. There would not have been any change in the momentum, right? So if we do not apply any force on an object, its momentum will remain constant. It will not change. So that's what law of conservation of momentum is. As we know, F is equal to delta P over delta T. Okay, change in momentum over change in time. If F is 0, if you do not apply any force, it means delta P will be 0, which means P has to be constant. So if force applied on an object is 0, its momentum will remain constant, or momentum is conserved. So you can write in a statement form: if force applied on an object is 0, momentum is conserved. That's what law of conservation of momentum. And it has huge application. A lot of question comes in exam based on law of conservation of momentum. Okay, so you can apply this concept. Let's quickly see one question. on law of conservation of momentum. So let's say this is 2 kg object. It is moving with 5 meter per second, and here is 1 kg object. It is moving with 3 meter per second. So they collide with each other, and after that, this 2 kg moves with 4 meter per second. So what will be the speed of v? We need to find what is the speed of this 1 kg object. That's what we need to find out. So as you can see here, there is no external force acting on this system, these two blocks, these two spheres. There is no external force acting on it. So the momentum before collision has to be equal to momentum after collision, right? So we can write momentum before collision. So this is 2 multiply 5. This is momentum of A, plus, because both are going in the same direction, so there will be plus sign here. 1 into 3. This is the momentum before collision. What is the momentum after collision? 2 multiply 4 plus 1 multiply V. So we can find out the value of V from here. Okay, that's 10 plus 3 is equal to 8 plus V. So 13 is equal to 8 plus V. So V will be equals to 13 minus 8, which is equal to 5. So V, the speed is 5 meter per second. But if this question comes in a different way, like let's say this is 2 kg, it is moving with 5 meter per second here, and another is it's moving this way, 3 meter per second. This is 1 kg. This is before collision, and after collision, 2 kg moves with 3 meter per second, and we don't know where this 1 kg is moving. Okay, so let's say 1 kg is moving right side, and if we are assuming it is moving right side, if the v value comes negative, it means it is moving towards left. Okay, because we here we have pointed, we are taking v as right side as positive. Okay, so left side will be negative. So here the momentum of this particular block before collision will be negative, because we are considering right side as positive. So see, we are going to apply the concept here. Momentum before collision equals to momentum after collision. So 2 multiply 5, this is the momentum of A, minus 1 multiply 3, this is the momentum of B. Why we are writing with minus sign? Because momentum is a vector quantity. We need to consider the direction as well. So here it is moving towards left, that's why we are writing with negative sign, equals to 2 multiply 3 plus 1 multiply V. So here we got 10 minus 3 is equal to 6 plus V. Okay, so 7 equals to 6 plus V. So V is equal to 1 meter per second. So this, as we are getting positive value, it means it is moved the direction we assumed that it's moving towards right is correct. So it's moving towards right with 1 meter per second. If this value would have got negative, it means the answer magnitude would have been correct, but the direction would have been negative, like it would have moved towards left. But right now, as we are getting positive value, it means it's going towards right. So that's how we do momentum question. Let's do other question on momentum. So which of these is the correct definition of momentum and its unit? So momentum is product of mass and velocity. So this is wrong. This is also wrong. Momentum is v divided by m. That's wrong. This is also wrong. Momentum is product of mass and velocity, and unit, as we know, that so force is delta p over delta t, right? So Newton per kg, momentum is Newton per kg. So delta p is Newton second or kilogram meter per second. This is wrong. This is also wrong. See here, this is right, but unit is wrong. Okay. Uh, uh, if we write v is equal to p over m, so p will be equals to mb. Okay, this is very important. Okay, so you keep in mind, huh? See, directly we saw d is was right, but the unit is wrong. Newton per kg is wrong. So so this cannot be the answer. The answer is C. As you will do a little manipulation here. I thought D is the answer, but its unit is wrong. That's why it's not the answer. C is the answer because its unit is kilogram meter per second and V is equal to P divided by M. So P is equal to MB. That's why answer is C. Which statement correctly describes the law of conservation of momentum? Law of conservation of momentum is if the force is zero, then momentum before collision equals to after collision. Okay, the momentum before collision is less than wrong. The momentum before collision is same as this seems right. The momentum before collision, this is wrong. The sum of the momentum before and after the collision is zero. That's wrong. The momentum before the collision is same as after because there is no force acting on it. Complete the following sentence. Impulse equals to, so impulse is force multiplied by the time or change in momentum. Okay, so that C is right. Now question number 4. A dummy is used in a crash test to investigate the safety of new car. The deceleration of the dummy and the passenger compartment is measured. The deceleration of the dummy is less than the deceleration of the passenger compartment. Okay, so why this is benefit for the safety of the passenger? So if the deceleration is less for the dummy, right? Because force is equal to mass into acceleration, and deceleration is a kind of acceleration. Okay, so if the deceleration is less, then the force acting on the dummy will be less. So that in place of dummy, if there would have been a real person over there, the person would have got less force acting on it, and it is good for the passenger, right? If the less force is acting, less injury will happen. So so the force of impact on the passenger and therefore harm is reduced. Okay, so this is the right answer. Let's say why A and B are wrong. Seat belts, crumple zones and airbags all absorb energy from the crash. That's wrong. The crash happens so quickly so the passenger does not feel anything. No, that's also wrong because if there is acceleration, there will be force and passenger will feel, right? The only thing is if the deceleration is less, force will be less. So less chance of injury. The time over which the collision happens is elongated for a passenger. That's correct. If the time is more, the force will be, because we know that the force is delta p over delta t. Okay, so if delta t is more, force will be less, but here it's saying for the safety of the passenger. Okay, so say for the particular this statement, for the safety of the passenger, the force of impact will be less. So this is the most appropriate answer. D is a right statement, but that's not satisfies the question. Okay, that's why option C is right. A roller coaster speeds along a track with a considerable momentum. If a different roller coaster travels at a 4 times the speed but half the times mass, then the momentum will be. So we know that product momentum is mass multiply velocity. Velocity is like a speed. So if you are multiplying this by 4 and we are multiplying the mass by half, so sudden the overall impact will be double. So that's why option B is right. Now let's quickly see theoretical question. So this is a dummy. Okay, the car approaches a solid barrier at 20 meters per second, crashes into a barrier and stops suddenly. Calculate the momentum of the dummy immediately before the crash. So momentum is mass multiplied velocity. So 70 multiplied 20. Okay. So 70 multiplied 20 is 1400 kilogram meter per second. That's the answer. So 1 mark for this and 1 mark for this. That's the answer. Rewind the impulse that must be applied to the dummy to bring it to rest. So impulse is nothing but the change in momentum, right? So change in momentum, final momentum is 0 minus initial momentum is 1400 kilogram meter per second. So the answer is 0 minus this is negative. Even if you write positively, it doesn't matter. But the actual answer is negative 1400 kilogram meter per second. It crash in the crash test. The passenger compartment comes to rest. So this is the time is given to you. The deceleration of the passenger compartment. So here we are looking for the deceleration, right? So how can we find out the deceleration? Let's say, okay, final velocity is 0, initial velocity is given, so we can find out easily. So a is equal to 0 minus initial velocity is 20 divided by 0.2. Okay, so you will get negative 200 over 2, which is negative 100 meter per second square. So deceleration, if acceleration is negative, so deceleration will be positive. Answer is 100 meter per second square. The seat belt and the airbag bring the dummy to rest. The dummy has an average acceleration of 80 meter per second square. Calculate the average resultant force. So average acceleration is 80, mass is 70. So force is mass into acceleration, 70 multiply 80. So 5600 Newton. That's the answer. The deceleration of dummy is less than the deceleration of the passenger compartment. Why? Explain why it is benefit. So in the previous mark MCQ question, we discussed that if the deceleration of the dummy is less, it means the force of impact on the dummy is less. Okay, and the force is less, there is less injury to the passenger. So that's why it is the benefit for the passenger. So that's what you can write here. Yeah. So I think the momentum concept is clear to you. It's very simple topic and small topic. Only thing you need to remember this: force is equal to rate of change of momentum. That is change in momentum divided by time. Okay. And from here you can derive this force is equal to mass into acceleration. And when you are solving these kind of questions and two blocks are moving, so do consider the direction as well. Like in this case, these were moving uh, in opposite directions. That's why here we have taken the momentum of B as negative. Okay, that's very important. And one more thing, the way question comes, like let's say this is 3 kg. Okay, it is moving with 10 meter per second. It strikes the wall and moves back with 10 meter per second. Okay, there is no change in the speed, only the change in direction. So the question comes like, what is the change in momentum? Generally students write the change in momentum is 0, because they say 10 multiply 3 is 30, again 10 multiply 3 is 30. So final momentum is 30, initial momentum is 30, they write 0. That's wrong, because here the as we are writing the change in momentum is a vector quantity. Okay, so you need to consider the direction as well. So here initial momentum is magnitude is 30, here the final momentum magnitude is 30, but we are talking about the change in momentum, that's final momentum. If you are considering left side is negative, so and right side is positive, so final momentum minus initial momentum, so final momentum is minus 30, initial momentum is 30, which is minus 60 kilogram meter per second. Or other way, you can also consider left side as positive. So the final momentum is 30, Initial momentum, as we are considering left side as positive, so right side is negative. So initial momentum is minus 30, 30 plus 30, which give you 60. So the concept here is that you need to consider one positive and the other negative. Okay, so sometimes they ask like this, like it is moving with v and here also v. So final momentum, the change in momentum, like see here is a m is the mass, m is the mass. So if we are considering left side as positive, so final momentum is mv, initial momentum will be minus mv. So you will get 2mv minus mv plus mv will give you 2mv. So that's the important thing. Or even if you are getting, even if you're writing with minus 2mv, that's also right. Okay, do not write 0. It's not 0, either it is 2mv or minus 2mv. I hope the concept is clear to you. Do visit our website www.victoryonlineacademy.com and register for free demo session over there, and we'll help you to excel in your grades. Thank you very much.